We're going to look at some maxima and minima problems. So the example that you have been given is a child playing with a yo-yo, and we've got an equation here for the distance, s meters, of the yo-yo from the child's hand after t seconds, which is s equals 0.6t plus 0.4t squared, subtract 0.2t cubed. And we've got here the restriction that 0 is less than or equal to t, which is less than or equal to 3. Now part A asks us to justify this restriction. So if we look at our equation for the distance here, s, now this is obviously a cubic. Now in order to justify a restriction, we're going to have to sketch this cubic. Now at the moment, the coefficients are not very nice at all. So we're going to try and find a common factor in all these coefficients so that we've got a cubic in a bracket where the coefficients are integers. So we can actually see here that a common factor of all these coefficients is 0.2, or a fifth. So we've got a fifth, we've also got a common factor of t, and then we've got a fifth t times 3, that will give us 0.6t. A fifth t times by 2t, that will give us 0.4t squared, because 0.2t times 2t is 0.42t squared. And then we're going to subtract t squared. We can then factorise this bracket here, and we get inside the bracket 3 minus t, 1 plus t. Because we had to find our factors of 3 that make a sum of 2t, but we've got that 1 positive and 1 negative value of t to get that negative t squared. So we've got a cubic. The roots of our cubic are, well, we've either got that a fifth of t equals 0, which implies that t equals 0. 3 minus t equals 0, which implies that t equals 3. 1 plus t equals 0 implies that t equals minus 1. Now we have not got a y-intercept because all of our terms here have a factor of t. So if we were to draw a sketch of our cubic, so we've got our t values are the horizontal values, we've got our s values, that's our vertical axis, our y-axis. We've got roots at 0, minus 1 and 3. So we've got a cubic that looks, it's a negative cubic because our t cubed coefficient is negative. So we've got a cubic that looks something like so. Now you can see here that s is positive for all the values of t between 0 and 3. So between 0 and 3, our distance away from the child, the distance of the yo-yo away from the child is positive. So this means, and then also, our t values have to be positive. So we're going to have to disregard any t values that are less than 0. So we've obviously got some positive s values here, but that's when t is negative. We know that t is our time value, so that can't be negative. So we know s is positive for all values of t between 0 and 3. S is less than 0 for t greater than 3. And since since s is a distance, the model is not valid for t is greater than 3, and s is equal to 0 at t equals 3, at t equals 0 and t equals 3. So we can have t equals 0, we can have t equals 3. We can't have a valid model for t is greater than 3. So we must have 0 is less than or equal to t is less than or equal to 3. For part B of the question, we're asked to find the maximum distance of the yo-yo from the child's hand, correct to 3 significant figures. So we're going to differentiate our equation for the distance, s, and then we're going to set that to 0. So remember that when we differentiate, we are finding the gradient. So when that curve is at its maximum point or its minimum point, that's when the curve has a gradient of 0, because that's the turning point. So that's where it's going to turn and change direction. So we've either reached the highest point and it turns and goes back down, or we reach the minimum point where it turns, gradient 0, and goes back up. So we've got ds by dt, that's equal to 0.6 plus 2 lots of 0.4, that's 0.8, and then we're taking 1 away from the t in t squared, sorry, 1 away from 2, which is 1, so we end up with t, and then we're subtracting 3 times 0.2, that's 0.6, 3 take away 1 is 2, so we've got t squared. We're going to set ds by dt to 0, so we get 0.6 plus 0.8t subtract 0.6t squared is equal to 0. I'm actually going to multiply all of this by 5, and by multiplying it by 5 I get 3 plus 4t subtract 3t squared equals 0. I'm then going to multiply both sides by -1 so that we get a positive t squared coefficient. So we get 3t squared subtract 4t subtract 3 equals 0. I'm then going to use the quadratic formula to solve this quadratic in terms of t. So we're going to find our t values. So t is equal to minus b plus or minus the square root of b squared minus 4ac, which is 4 squared, sorry, negative 4 squared minus 4 times 3 times negative 3 all over, or divided by, sorry, 2a, which is 2 times 3, which is 6. Now, if you put this in your calculator, you'll get 4 plus or minus the square root of 52, all divided by 6. And then if you put this into your calculator, we're going to get, for when this is adding, we get a value of 1.8685 and so on. When we're subtracting that root 52, we get negative 0.5351 and so on. So here we've got 2 values of t when our distance is at its maximum point. Now we know t is time, so it's got to be positive. So we're going to take this value here. So at this time, our distance is at its maximum point. So we need to then find that distance. So we're going to substitute this value of t into our equation of the distance of the yo-yo from the child. So we've got 0.6 times by t plus 0.4 times by t squared subtract 0.2 times t cubed. And when we put this in our calculator, we get 1.2129 and so on. The question has asked for it in 3 significant figures. So we get 1.21 metres to 3 significant figures.